Did y'all have trouble? I don't have the answers. Do you? I love it. No, I love it. I love it. It is. It is. It is. Okay, but whenever it's a square, you just square it.
Wait, how do you know if it's not?
It says, like this says, for this solid, each cross section is a square. So it's the area, but it's always the area of the shape, and then you just integrate. The area of the shape.
Are these all these calculated?
No.
What if these were calculated? They probably weren't, right?
No, they definitely were. Because through to X.
What's X to the 1/2? That probably actually would not be, yeah.
Either way.
When you get to something like, probably like 5 would be a calculator. I don't know. Most of these might be non-calculator. Right, right. And the only time that would really make a difference too is if you're multiple choice and the questions are in exact form. You know what I'm saying? All right, we'll do the first one. Y equals x squared. Y equals square root of x. Parabola. And I'm intentionally just doing this first quadrant because that's what they have. Square root of x. So you got to be able to recognize which one's on top, right? Because that matters. Square root of x. X squared. All right, so what are we doing first? Perpendicular to the x-axis. So here's my cross section. Agreed? What is, I forgot my steps now that I told y'all to do, but what is my cross section length here? That's right. So it's the top minus the bottom, right? So it's square root of x minus x squared. So since I'm doing a square, the area of my square would be that squared, right? Oh yeah, this probably would be a calculator. Sorry. Yeah, yeah. To me it would be 2. No, you don't. Mm-hmm.
Oh yeah, I didn't know that either, but I kind of like. Yeah.
I had to do the same thing on the Y. Yeah.
Yeah, yeah. All right, so integrating, I know I'm going from 0. I know they share this point 0, but I need to know this point of intersection because that's going to be my other bound. That's going to be my upper bound, right? Say right to this, right? Okay, thank you. So I'm going from 0 to what? What is this point? 1. What is 1, 1? Yes? And if you didn't know that, how could you find that? Okay, if you couldn't tell what it was on the graph, how could you find it? How could you algebraically find it is what I'm getting at. Set them equal to each other, right? Drop the y's off, set them equal. So square root of x equals x squared. Where does that happen? Kind of thing, right? Y'all okay? Okay. That's right. That's that intersection point. That's where they share. So we know that's 1. And now I'm just going to do the area of the square, which is square root of x minus x squared, squared. And then you just put it in. What'd you get? Give me one more. Oh. 0.1289. 86.
I was wondering why there was a 3 up there.
I don't know. I thought that's what y'all said. All right. Put up to 4 a.m. Moose was eating his foot again. Moose was eating his foot, you know, from his foot. Can't do it anymore. So the way he lays, he can get his foot, if he's got a cone on his head or anything on his foot, he can tuck his body up to literally where his chin comes to like about his joint. Well, but it's like an open source, so it can't stay sealed up that long. You know what I'm saying? It'll get infected. Right there.
Oh, that's
I don't understand. I get so mad, and I'm like, what is wrong with you? Why do you keep eating it? I know it hurts. Like, it hurts because I touch it and it hurts. Why do you keep hurting yourself? I don't understand. I thought he was anxious. We thought, hey, something's got to give. Honestly, we can't. We would have to put him down before we can amputate it because the vet talked about that. But because he's a great man and he's so heavy, his body can't support the weight without the fourth paw. Yeah, because we discussed that option. But then he just licked the stump. I mean, what's going to keep him from licking that? Okay, let's don't talk about this anymore. Let's do with respect to y. So our cross section changes. Now this is my cross section. Right? Okay. So now I am going to solve, the equations remain the same. So this is still the same equation. It's just different. Written a little different. So this is square root of y equals x. This time though, I have to do with respect to y. So I'm going, now this is easy to get confused because my x and my y's are the same at each point, 0, 0, and 1, 1. But if they were different, I'm going from the y values here instead of, the x values. And then I'm going to do right minus left. So square root of y minus y squared. Squared because it's still a square. But when I put it on my calculator, I still use x. The variable itself doesn't matter. It should give you the exact same answer. Does it not? Let me see. Y'all didn't?
I got it.
No.
I didn't think it would though. I kind of thought it was wrong.
Square root of y minus y. I'm thinking that it should.
I don't know. That means you didn't square it. Because I didn't square it at first.
I got 0.12857. I literally put all of this in my y1 so that I didn't have to do any practice. Yeah. Yeah. All right, y'all ready to do another one? A little bit harder one? Really? Why did I only run squares?
There's a circle right here. Is this not a circle?
No, but you're still using squares. We'll practice squares next.
Yeah, how do you do a rectangle one? It's like a,
It should give you the height each time, which is a constant height. You just pull it out.
I don't really.
Okay, I'll show you. Oh, well. Yeah. What did it say section this was? Oh, 8. This is that section. All right. Let's do one with a rectangle. Then I'm gonna do one with another shape. What do you feel of rectangle one? 3. All right, let's do 3 then. The base of a solid is bounded by y equals x cubed, and you have this nice little graph given to you. That's very kind of them. There's my x cubed. Y equals 0. Bless you. So in other words, the x-axis, and x equals 2. So this is x cubed. This is 2. This point then should be what? 2, 8. And here is my region. Find the volume if the cross-section's taken perpendicular to the x-axis, so with respect to x. So I already know my cross-section is going from here to here. Form a rectangle whose height is 2 times its width. Let's draw a picture. This is my rectangle that's being pulled out, yes? Pretend. There's my rectangle. Actually, it's more like a square than a rectangle, doesn't it? Okay, we'll do it like this. Height is 2 times its width. So let's call this the width, and this is the height, or it doesn't matter what you call it. But okay, the height is twice its width. What in the world? Okay, so height is 2w, but still I've got to be in terms of my cross section. So this is my cross section, yes? So I'm going to call that the width here. The width of the rectangle always sits from the cross section because it's coming up from the base. It's like the base of it. Let's consider it. All right, so what is the width of that rectangle? In terms of x. X cubed. Does that make sense?
No.
Look at my cross section in the picture.
Yep.
This corresponds to this. These are the same. So what is that distance?
That would be the height. Yeah,
But it's right.
But why is the height going back
No.
there?
It's sitting like that.
Yeah, but that's how you have it drawn.
No, it's sitting like this. You see what I'm saying? Like this is the width, this is the height. This is what's sitting on the.
Yeah, that's what I thought.
What are you asking?
Like there's a bunch of little calculators of different widths here that are stacked up.
And there's like a plane going on that. And then that's the width. What you just said doesn't make sense.
Yes, but it's changing by this equation. Like this is x cubed, which means the height is twice that, which would be 2 times x cubed.
Does it matter if we know y is that the width is the...
I think y'all are thinking. Okay, so yes, if you're looking at it like this, it's coming out like this. But if I'm, yes, not the width of the line itself, because think about it being paper thin, because I'm doing an infinite number of these shapes.
But the top line on.
Yes.
Okay, I'm
Okay, I think about it sitting on my desk right in front of me and coming up. But if you're looking at it like this, yes, it's coming out to you. No, Robert?
I don't need to know though. I feel like I can just know that.
Okay, so come straight. So remember, the goal is to find the area of one cross section. If I can find the area of one cross section, then I can integrate to find the volume of the whole thing. Okay. So what is the area of just one cross section? Take out one sliver and find the area of that rectangle. What is it? X cubed times 2x cubed, which would give me 2x to the 6. That makes sense. It's volume. So to find the volume, I'm going to integrate from what to what? From 0 to 2, 2x to the 6. Yeah. I would say this is probably non-calculator. This is pretty easy. No. 2 over 7, x to the 7th, 0 to 2. 2, 4, 8, 16, 32, 128. I'm just doing it in my head, but you can use calculator. 256 over 7. Okay, so in an FRQ situation, though, just leave it right there. Don't try to take that out any further. Now, for your multiple choice, you'll need to know. But most of the time, every now and then, you'll get something where you have to come over to the side and do like some old school multiplication, like 2-column multiplication. But it's very rare. Most of the time, it's stuff that you can do quickly in your head. Yeah, why do you think it wouldn't? Well, what's 1/2 to the 3rd power? 1/8, right? So I still got a little bit. It's teeny tiny, but it's still a little bit of area until I hit 0. Do the same thing, but do it with respect to y. Smart, set, go. Change your cross section. Now, instead of coming out this way, it's coming out this way. Does that make sense?
Does the width change too? Or wait.
This one you're going to have to do a little subtracting, right, to find out. Here's my cross section. Right.
Doesn't give you the height. I would just think it was 6 times 3 that area.
Where,
I mean, that's kind of what I'm thinking.
I don't think you're doing it right now. I can't.
But I gotta.
Are your dimensions of your rectangle the same as the dimensions of my rectangle? 2 minus cubed root of y.
Oh, what?
Where does it? Oh, I didn't even look at B. I was just doing it the same way I did the other. Okay. Don't look at B.
All right, redo this.
No, because that was the stipulation for part A. But I kept that stipulation in what I did. Keep everything the same. Don't look at this. Look at what I did. Don't look at what I told you to do, not what they did. I'll do it with 6 in just a second and show you how that changes. If I left everything exactly the same as the initial setup of the problem, right? And I told you that the height is double the width, I can still do that with respect to y. Well, because now I'm with respect to y, right? So I'm going right minus left because there's a hole here. As I measure this distance, because I need to know how wide this is. As I measure that distance, I've got a hole, H-O-L-E hole.
I mean, yeah, we had that before.
No, because it sat on the x-axis before. I didn't. If I was perpendicular to the x-axis, it sits on it. And so that's what you got to look for. Is there a hole or is it sitting on the axis? If there's a hole, H-O-L-E hole, you have to subtract out. Because whenever we get to volumes, we talk about hole versus hole, like W-H-O-L-E versus H-O-L-E. And I'm just used to spelling it. Because this is the whole thing, W-H-O-L-E. This is the whole, H-O-L-E. All right, do y'all see how I got this, though? Okay, so this cross-section, if I go all the way across, we know that to be 2, right? That length is 2. Now I take out the whole, which is cube root of y. So this is my cross-section. Does that make sense? Right minus left, right minus left. I'm doing it with respect to y. Same thing we've been doing. Then I just doubled that for the height. Does that make sense? We're not doing B. We're doing it a little bit differently right now. If we were doing 6, yes, that would just be 6. I wouldn't do double the height. So either way you do it, it still works. All right, so I'm going to do the integral. What are my bounds here? That's right. Look at, because you're doing it for y now and not x. So bottom up. That's the point where they intersect, 2, 8. You're talking about this too? The point 2, 8? No, that's I got to do right minus left. Say that again. Say it, explain it one more time. You changed.
Instead of writing it out how you did,
Mhm.
I changed the 2 in front of 2 minus cube root y to 3.
Yes, because there's 3 of them.
Okay,
Yes,
that's what I'm
yes, 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 yes. No, that would be if I was adding them. What I could do, though, Madison, is I could write 2 times 2 minus cube root of y squared. Because I'm multiplying that. If this was plus, you're exactly right, I could do that. But I'm not, I'm multiplying. So it's this times this, and really I could put this like this. So I've got 2 of these 2 minus y. It would have been infinitely easier if I had read part B and we'd done it with a height of 6. I've not seen that a whole lot, though, where we get a constant height. But if we did, just to show you, that would mean it doesn't matter what the width is, the height is a constant 6. Okay, so my shape is not fluctuating at all. It's just always this height of 6 as I go across. The only thing that's changing is the width of my rectangle each time. But it makes the integrating a lot easier because the integral would be from 0 to 8 of 6 times 2 minus 2 to the y. What, the calculator? Yeah. The more complicated it does get. Take this same shaded region. Are y'all ready?
Wait, Jordan?
Yeah. Right here. Whatever it comes out to be on your calculator.
No.
Yeah, that's height of 6. Oh, no, but I will.
No. Wait. No, I just don't even know. I didn't even start at that.
Well, everything's the same. The only difference is it's not twice the width. It's just a constant 6.
But wouldn't width be 3?
No, because take twice the width out of your brain. That only applies to part A. If you change to part...
I don't want to get it.
What?
I feel like don't if you go on AC, like it carries over all the time.
Well, it does. That's why I kept on going and I ignored what it said about that, and I just did it with respect to y. I didn't read the problem, but whenever I read it, it says, but look, because look, on 3, this is more AP style what we did the first time. Instead of a constant height. That's why I did it that way with you. Let's do another before I give you a circle. Thought we were ready. I what? I did, I'm sorry. Let's do number 4. Well, that's still a square. Square. 7.
Well, I don't know about that pie.
Okay, yeah, let's do 7. The y-axis, y equals sine, and y'all, seriously, most of the time, you very rarely get a picture drawn for you. I kind of hate that. I should have, covered that up whenever I know, but I don't want you practicing with the way it's not going to be. All right, and the y-axis. This tells me right off I'm probably going to be doing with respect to y, but we'll see. A lot of these you can choose what you want. You don't.
Oh yeah, we will because the bounds are X.
And not only are the bounds X, but why is y a little bit easier to do as I look at it? It sits, that's exactly right. It sits flush on that axis, right? If I go with respect to X and I'm perpendicular to, oh no, I do have to do, it says each cross section perpendicular to the X axis. Okay, we'll do what it tells us to do. What the heck? But you do see why it would be easier to go from the y-axis, right? It's sitting on it. It's not, there's no hole or gap there.
And what would we do? We find y equals sine X, like right.
If you were doing it the other way, yes, it'd be the inverse sign. All right, so this point, pi over 2, 1. Agreed? Disagree? Please agree, because that's right. Okay. This is sine X. Rectangle. Rectangle whose height is 3 times its width. Bless you. All right, y'all ready, Freddies? I need close, but you're not taking the hole out. There you go. Right. Does everybody see that? That green cross section right there measures to be, yeah. Yes. If it's with respect to x. If it's with respect to y, it's right minus left. All right, so I know here my height, or actually, my width.
Isn't that something? 1 minus sine.
1 minus sine squared is. All right, so my width is going to be 1 because it's this top line minus sine x. Everybody agree? Which means my height 3 times that. Which means my volume, I'm going to integrate from what to what? I'm with respect to x, 0 to pi over 2. It's just going to be this times this. 3 times, and I'm squared. That's exactly what I did. Okay, length, height, same thing. I just say height because it's three-dimensional. So, okay, for volume, yes. But I'm integrating, which is giving me the volume. We are. We're using calculus to get. Yeah. Geometry. Does that make sense?
Yes, but I do have a question.
Okay.
So, if on the squares, I thought on the squares where we subtract the top line from the bottom, or you do whatever.
If there's a hole. This one had a hole. See all that white space under?
Yeah. I was just trying to like.
I don't know. I don't. Hold on. 1 minus sine x squared. Y1 x. This one's 1.0686. Get in the habit of going ahead and going out 4 places. Yes. Which one? This one?
And the one that
The one that I have 6 in? Let me see.
the one that you have circled in the red.
2 minus the cubed root. Hold on, I'm gonna get this one for you. The one circled in red. It's taking a long time. Okay, my calculator does not like it. 23.99999. Okay, is that what you got? Okay. Didn't get what? Take this same region. Actually, let's keep it perpendicular to x. But let's say that the cross sections are semicircles.
Oh, 1/2 pi r squared.
Find the area. Find the volume. So the semicircles, like if you cut a circle in half, its diameter sits as the cross section, so that it comes up or it comes out to you as a circle. Yes. Yes. Yes.
1/2 pi r squared.
Right. So the cross section is the diameter. Yes. If the cross section is the diameter and you need the radius, what's the relationship between diameter and radius? Half of it. You already did the work to find this. That is 1 minus sine x, right? So that means that is my diameter of my semicircle, right? So what is the radius? Half of that. So the radius is half of 1 minus sine x.
Really, it's just 1/4 pi.
Right. Why are you doing that now? Why 1/4? Explain to everybody why it's 1/4. 1/2, because it's it's half of a circle, right? So a whole circle is pi r squared. So a half a circle is 1/2 pi r squared. Y'all okay? So the area of the semicircle would be a half of pi times a half pi. It's actually going to be 1/8. It is. It's pi r squared. Right.
Oh, I thought you were.
So this is the full circle, but the 1/2 is because it's a semicircle, right? Pi r squared. Yes. And I would plug it in exactly like this to keep from making a huge stinking mistake.
0.089.
Do one with respect to y? Sure.
Really? You do that?
So the area of a full circle is pi r squared. Pi r squared. My diameter of this circle is 1 minus, yeah, so I have to cut it in half to find the radius.
We all got. I got 0.089. I'm missing yours.
All right, 0.5 times pi. 0.5. 1 minus sine x dx was the 1 minus sine x. That's what gets squared. 1, 2, 3, 1, 2.
0. No, 0 pi. What'd you get? That's different than what we.
We're going. Wait, are you going from 0 to pi over 2? 0.27975.
All right. What the heck? Why? Where is it? No, it isn't. Yeah, well, you're supposed to have the 1/2. Yeah. Oh, yeah, you are. Yeah, you are.
Me?
No, I got the same.
No, lady, I don't know. It's not really a good reason. Well, I just feel like we know.
I did 0.5s instead of 1/2 to lessen my parentheses.
So,
And then make sure when you're squaring that all of this is being squared. Or you could do, if you want to do pi over 8 times 1 minus sine x squared. That might be easy. I'm going to put parentheses around this pi over 2. Over 2. That takes care of that one.
all right, so, I'll do for time.
Over 2. And you got one, 2. What do you get if you put pi over 8, 1 minus sine x squared? Is that what you got when you did that? Okay, well wait, let me make sure I put mine in right.
All these parentheses.
If you square this, so you take this to this and this, so you got 1/2 times pi times 1/4. Why are we getting? There's a reason. 2.